Okay, now we will discuss the first case of aldol condensation reactions. If the reaction takes place between two different unsymmetrical ketones, you know what are the unsymmetrical ketones? If we have different alkyl chains on either side of a carbonyl group in a ketone, these type of ketones are the unsymmetrical ketones. What happens? Now we have two different type of active methionine compounds. When you treat this one with the base can also remove a proton from here to give you a carbene ion of this type, and also can remove a proton from here to give you a carbene ion of this type. So two different types of products can be formed. If this type of carbene ion is formed, this carbene ion will attack on the carbonyl carbon, and this negative charge will get the proton, and we will get this type of product. And if the base will remove proton from this carbonyl active methionine, and this type of carbene ion is formed, this carbene ion will attack on the carbonyl carbon of ketone, and we get this type of product. These two products can be formed, but in general practice it is experienced that this type of product is not formed, but this type of the product is favored due to steric hindrance. Why? Because this carbene ion is formed on the terminal carbon, and is very easy to attack of the terminal carbon to the ketonic carbonyl group, which is already sterically hindered. However, for this carbene ion, which is not on terminal but in the center carbon, this is very difficult for this carbene ion to attack on the carbonyl group. So it is a general practice that that type of carbene ion is formed, which is more easily to move and at a terminal carbon atom. So terminal carbon active methionine compound is formed, carbene ion, and it will attach to the carbonyl group. So the reaction takes place more preferably to the terminal carbon. Okay, now we will discuss the second case of aldol condensation reaction when we have mixed reactions. It means when we have two different types of aldehydes, then what happens? So if we have two different types of aldehydes, then it is not suitable because we will have more than one product. So this reaction is not feasible, not important for the industrial method. However, if we use two different types of aldehydes in which one aldehyde has more reactive carbonyl group as compared to other one. So what happens? Then when aldehyde forms the carbene ion always attack on that carbonyl carbon that will has more reactive carbonyl carbon, and that carbene ion will not attack on the aldehyde which has less reactive carbonyl group. For example, if we carry out a reaction between acetaldehyde and carbene and formaldehyde, you can see that acetaldehyde has a carbonyl group in which one methyl group is attached, but the formaldehyde has a carbonyl group in which two hydrogens are present. So this one is more reactive due to steric hindrance, less steric hindrance. So carbene ion which is formed from acetaldehyde will always attack on this one. And second, the formaldehyde has no active methionine carbon, so no carbene ion is formed from the formaldehyde. So what happens when you treat acetaldehyde and formaldehyde in a base? The base will remove a proton from this acetaldehyde carbon, carbene ion is formed, carbene ion attack on this formaldehyde, and formaldehyde becomes attached to this CH2OH like this one. This is part of acetaldehyde and this formaldehyde is attached. The reaction will not stop at this step, and the base will further remove one proton from this carbon, which is a carbene ion, and carbene ion is formed, and this carbene ion attack another molecule of formaldehyde, and another molecule of CH2OH formaldehyde become attached to this one. Reaction will not stop because still this active methionine has one proton, so base will remove the proton from this carbon, the carbene ion is formed, this will again attack another molecule of formaldehyde, so this reaction takes place. So in step, one molecule of acetaldehyde will react with three molecules of formaldehyde, and three molecules of formaldehyde will become attached by using CH2OH. So when we reduce this compound, this aldehyde is reduced to alcohol, so this type of compound is received, and this type of compound is produced, and this compound can be like this one, and this is called a pentaerythritol compound, which is very useful, and explosives can be made by the nitration of this pentaerythritol. So this is the importance of aldol condensation reaction. By using one acetaldehyde and three molecules of formaldehyde, we can make this pentaerythritol by aldol condensation reaction. Now the third case of aldol condensation reaction, if we use different one aldehyde and ketone to carry out a reaction under the basic conditions, so this reaction is also not useful because different types of products are formed. For example, this aldehyde will make a carbanion and attack on ketone. This aldehyde will make a carbanion and attack on itself. The ketone will make a carbanion and attack on aldehyde. So two different products are formed. One from the carbanion of aldehyde and attack on same aldehyde, and one from the ketone carbanion attack from aldehyde. So these reactions are not useful, they are not important because more than one products are formed. It is very difficult to separate all these products. However, if we carry out a reaction in which the aldehyde contains no alpha hydrogen, so if no alpha hydrogen is present, so the carbanion cannot be formed from aldehyde, and we use a ketone. So always carbanion will form from ketone and it will attack on aldehyde, and in this way only one product is formed. For example, if we take the examples of reaction between the benzaldehyde and acetone in the presence of base, then this is a successful reaction and we will get this product. This is the reaction. So in this reaction always the water is removed, the hydrogen from here and hydroxyl group from here. This is not a product. So always a product is formed with the removal of water. This is called alpha beta unsaturated compound. Alpha beta So what happens in the mechanism, that when you treat a base, this benzaldehyde, when you show this one, like this one benzaldehyde, this benzaldehyde has no alpha hydrogen because this alpha carbon has no hydrogen. So only base will remove the carbanion from here. This carbanion is formed. This carbanion will attack on this. This cannot attack on the carbon of ketone because ketone carbon is not active. So this will attack on CO and a product is formed. So we know that at the end of the condensation reaction, in the basic conditions, hydroxyl from here and hydrogen from here is removed and a double bond is formed. So the condensation product is formed in the form of alpha beta unsaturated compounds. So this product is useful. So we come to know that if we carry out a reaction between aldehyde and ketone, we have to use an aldehyde which has no alpha hydrogen, and we use a ketone. Then this reaction will be successful. We will get only one product, and so this will be a useful reaction for the industry purpose.